Example number 3 is simply asking you to plot a graph that shows the force, the electrical force between two charges. So let's say you have this charge Q that is Q1 and it's positive. And then you have another charge here, we'll call that Q2. And we're looking at, we would see hopefully that the forces would be repulsive because they're like charges. But what would happen as you take these charges further and further away? How much did the force would it decrease? Or for example, if you started with R and then now you move to say 2R, well, if this original force was just simply F, how much will the force decrease by? And hopefully you realize that it will decrease because the force is directly proportional to the product of the two charges, which isn't changing. This is still Q1 and this is still Q2 in the different scenarios as we move them further apart, but it is inversely proportional to the square of the distance between them. So this new force in the second scenario will be equal to, say, K, Q1, Q2, but now it's 2R quantity squared. And hopefully you'll realize that will be a quarter of the original force. So now it's only 1/4 of that original force. Now if you move them to, say, 3R, then how much will that force change by now? And hopefully you'll see that since it's inversely proportional to the square of the distance between the two charges, if you do 3 squared, it's going to be now 1/9 of the original force. So if you were to plot the graph, say starting here, where's this point, and we were to look as R increase, what would the graph look like for the magnitude of the force and the distance as it moves further away from each other? And I would hope that you would realize that this would look like an inverse curve, but it's an inverse squared curve. So it means that it has an even sharper curve than a force is inversely proportional to R, but it's actually force is inversely proportional to the square of the distance between the two charges. And that's it for really example number 3.